Good afternoon, everybody. Today, I'll summarize, by taking the final this thing in the quantitative analysis, of assembly system. I'll summarize this particular portion, in the single station assembly line. Single station assembly and shell automation. So in the single station assembly, only one station is there. In that, now how you are going to calculate the cycle time, and the production time. How you are going to calculate a single station assembly? In that, we are doing only assembly at the single station. That is the you have seen in this particular chapter. You have seen what are the different types of assembly systems. That is L shape, U shape. That is the inline configuration. Configurations you have seen. One is inline configuration. Second one is the rotary configuration. And segmented inline configuration and single station assembly machine. So in that we have already learned about the inline configuration of the machine, and then L shape, U shape, rectangle shape, and the single station assembly. So these are the different configurations what we have learned. And today, yes, I'll just touch upon this single station assembly. This is the last one, and partial automation. Only these two are there. So with this, I'll summarize today this particular topic, and the total summary I will take within 15 to 20 minutes. So first of all, this single station assembly, in that 4 types of configurations. Workhead is, as I have explained, for the bottle filling station, there are n number of workheads are required, but for single station assembly, at a single station, we are doing that particular operation with the help of what we are calling, it is a kitty. Trucks are required. So kitty trucks will bring all the components at one station, and we are doing assembly at one station. So that is called kitting of parts. We are doing the kitting of parts by bringing those particular parts to the single station. At one station we are bringing all those particular parts, and we'll do the assembly of those particular parts at one station. So that is single station assembly. So now how you are going to calculate the NE, that is the number of distinct assembly elements that are performed on the machine. So how many number of distinct assembly elements you are going to perform on that particular machine? So that is here. So how many elements? And each element has an element time TEJ. So element time. So this is element time, and this is number of elements. Number of elements and element time. So where number of elements are the TEJ time is 1, 2, 3 up to NE. So how you are going to calculate? What are the in the single station assembly machine? How you are going to sum up the individual element times of the assembly operations to perform on the particular machine. So that is how you are going to calculate time. How you are going to calculate is equal to TH, that is the handling time of the machine or the element, handling time, and then summation of sum of this is we have to calculate this. This is about first. Now how you are going to calculate the production time, TP, average production time, what we are calling, calculated using your the MI into QI equation. In the last previous class, I have explained about that MI into QI. So that the terms, with the help of M is the probability of the defect. MI, that particular I, the defect, and that you have to take okay, and the QI, okay, is the defect, fraction defect of that particular part, okay. So here TC, okay, TP you are calculating with the help of TC plus summation of I is equal to 1 to N MI into QI, okay, MI into QI into the downtime, okay. We are calculating the downtime calculation for this, so we are using the downtime calculation, okay. So this is equation number 2, okay. So with this particular equation we are calculating average production time, that is your cycle time plus summation of I is equal to 1 to N. This is M is Q is the fraction defect and M is the component, okay, the defect, okay, the component. Because of that particular component, say like if a blowhole is there, okay, in the casting, so that may jam that particular station, okay, the component is defective, okay, and causes the jam, okay, that is your MI. So M is the machine, okay, at that particular point this thing will halt, so okay, so that is MI into QI, okay. So that is Q is the fraction defect, okay. So MI into QI into TD, where TD is the average downtime of that particular machine, okay, to clear that particular part, okay. Downtime is required to clear that part, okay, and restart the system, okay. You have to restart that particular system, so for that we require the downtime, okay. So with the help of that particular downtime we are calculating what is the average production time. So next is for the element, do not include the addition of the component. The value of Q, when Qi is equal to 0, at that time we are calculating, how we are calculating that MI is irrelevant, okay, that is the line stoppage is not there, okay. At that time the probability of station failure during element I, okay, and J, for the special case of equal Q and equal M values for the components added. So at that time the equation becomes TP is equal to TC plus N is number of machines, M into Q into TD. So this is third equation, okay. When QI is equal to 0 and M is irrelevant, that is the stoppage, okay, because of the defective parts will jam the station, okay. If that is irrelevant, then this equation holds good, okay. So this is about the single station assembly. Then last one is the partial automation, okay. In the partial automation, we have the two types. One is automation is introduced gradually on the existing manual line. Okay, automation is introduced gradually on existing manual line. Okay, so first one in that, so automation is introduced gradually on an existing manual line. Okay, so this is one. Second one is certain manual operations are too difficult. Certain manual operations are too difficult or too costly to automate. So these are the two cases. Okay. So in this particular case, now how you are going to calculate this the average production time. Okay. So how you are going to analyze this particular type of partial automation? It is partially automated. Okay. Analyze how you are going to analyze the performance of that particular line if it is a partially automated, if it is not fully automated system. Okay. So partially automated production line build on our previous analysis and make the following assumptions. So we are making the assumptions: workstation perform either processing or assembly operation. So either we are processing that assembly processing operation or the assembly operation. That is the first assumption what we are making in this. And second one is processing and assembly times at automated stations are constant through not necessarily equal at all the stations. So this is the second assumption what we are making here. The second one is processing and assembly times at automated stations are constant. Okay, the processing and assembly times are constant. We are keeping that particular, say whatever the assembly we are doing in station 1, 2, 3, 4 like that. So it is the time, whatever it is there, we are assuming that the times are constant at a particular station, okay, individual stations. Though not necessarily equal at all stations, okay, and we are telling that though it is not necessarily, okay, equal at all the stations, okay, but we are assuming that, okay, that it is constant. The system uses synchronous transfer of parts. Similarly, okay, the whatever the first case we have taken for the assembly line, okay, same. So it is using, the system uses synchronous transfer of the parts. Okay. Fourth one, the system has no internal buffer storages. In between the stations there is no buffer storage for WIP, work in process. Okay. And station breakdowns occur only at automated stations. So we are assuming here in the partial automation that the station is breakdown occurs, okay, at automated stations. So this is the fifth one. Okay. So the analysis we are five assumptions we are doing, we are making to analyze the performance of this partial automation. Okay. Then how you are calculating what is the cycle time? So TC, okay, is determined by the slowest the station on the line. Okay. Say one, this is say one line, this is another line, this is third, and this is the fourth line. So which one is the slowest, okay, cycle time? So idle cycle time TC, how you are going to determine? So it is by the slowest station on the line, okay, by a manual station. So in the slowest, which one is slowest in the manual station, that we have to check, and TC will exhibit certain degree of variability. So in each line 1, 2, 3, 4, so each variability, there is a variability of the line, okay, and variability simply because there is a random variation in repetitive human activity. So continuously the human is doing something, say like assembly operations. Okay. So we assume that TC remains constant over the time. Okay. So we are assuming that TC will be constant, and with the help of that, okay, and what is the PI is the probability of the breakdown per cycle. Okay. With this equation we are taking this probability, okay, of the breakdown per cycle, how many breakdowns happen in that particular line, that we are taking, and the perform the assembly operations, we are taking QI and MI, okay, that is the fraction defect and the components which will cause the station to jam, okay, that MI we are taking that as equal, okay, fraction defect and MI we are taking as equal. So the defect rate and probability that the defect will causes the station I, okay, to stop. Okay, we are, so I will stop that station. We are now in a position to define the average actual production time. So with the help of that, when these things are equal, QI and MI, then we are writing the equation TP is equal to, okay, so this is the average production time. So TP is equal to TC, okay, into PI into TD. So TC into summation, okay, so this is probability I is equal to 1 to n into TD. We are not taking here, we are taking the probability. Earlier case we have taken here TJ, that is element time we have taken, and we have taken calculated with the help of downtime. Okay. element T is equal to Mi into Qi. Okay. So here in this particular case we have taken Tc plus I is equal to n. Okay, that is I is equal to 1 to n. So here the summation, okay, whatever summation is there, that Na, okay, so n is there, so this summation, so here, okay, the sum, okay, I is equal to 1 Na, sorry, I is equal to 1 Na, so this particular Na, okay, so that is the summation applies to Na automated stations only. So only for that particular, so that's why we are taking station breakdown occurs at automated stations. Fifth assumptions what we are doing accordingly, if you see this particular equation, then this I is equal to I is summation to Na, okay. So that Na is the for the automated station only. So automated stations only perform the assembly operations, okay, and we in which the part is added, that partial automation, that the manual assembly is added, okay. So if all Pi, Mi and Qi are equal, okay, the probabilities, the line stoppage, okay, because of the defective parts will occur, it will cause the station to jam, and your fraction defect Qi are equal. So respectively to P, M and Q, then proceeding equations will be Na into Pa into D. So this is Tc plus Na into P into Td. So this average production time we are writing with the help of this particular equation, Na into P into Td. Okay. Similarly, how you are going to calculate the cost per component of that particular line. So how you are going to calculate the cost? Okay, given Na, if P is equal to M into Q, then how you are going to calculate? Okay. So given Na, there is number of automations, then Nw is the number of stations. Okay, Na and Nw is number of workstations. Na is the assembly. Okay, number of assembly lines. Say 1, 2, 3, like assembly workstation. Workheads are how many? Okay, with the help of that we are calculating what is the cost of that particular part. Co is equal to C0 is equal to C into A into T plus, that is summation of I is equal to N into A. Okay, sum of I into A is equal to C A S into I plus summation of I is into NW is the number of workstations into CW, that is workstation time. So this is equation number 1. Okay, so number 4, equation number 4. So this holds good when the total cost to operate that particular line. Okay, this is the operation cost, total operation cost. Okay, operating cost. So this is total operating cost of the line. Total operating cost of the line. Okay, we are with the help of this particular relation we are calculating that. Okay, so see when this cost of operating the partially automated production system, okay, in dollars per minute or rupees per minute, if you take for all CAI and all CW, that is workstations and assembly stations, if that is the case, then we are calculating this is CAT plus C into AS. Okay, so this Na. Okay, so here number of assembly line into CAS plus NW into CW. Okay, NW into CW. So this is the equation number 5. And then the total cost per unit produced. Okay, so next is the total cost per unit produced. Okay, so if you calculate this total cost per unit produced is CPC. How much CPC you are getting? CPC is equal to CM, that is manufacturing cost, okay, into operation cost plus the average production time plus C into T, that is a tool changing time, divided by P into AP. So this is the equation number 6. With the help of this, we are calculating what is the cost per component of that particular line. Okay, partially automated line. Okay, so with this, just this summarizing this particular uh, unit. Okay, in that, see, you have seen today the single station assembly line and the partial automation. So in this particular in this particular automated assembly system. Okay, I have already in the automated assembly system, I have taken fundamentals of automated assembly systems, parts, okay, system configuration, parts delivery at workstations, applications of that, the quantitative analysis. I have taken part delivery system at workstations, multi-station assembly machines, single station assembly machines, okay, partial automation. Okay, so this is the summary of this particular unit. Okay, so with this, okay, today I'll stop here, and this is the completion of the portion, okay, of sim, okay, for PG sim 4th semester. So if you have any doubt about this particular unit and the previous unit, okay, that we will be discussed. Okay, if you want any further clarification, you just call me, and I will explain. Okay, once again, if you have any doubt, okay, through telephone or through the web. Okay, Google Meet, okay, or WebEx, okay, any platform we can. I'll take this once again. If you want, then I will clarify the doubts. Okay, so today I'll stop here. So if you have any doubts, okay, you can contact. Thank you. So this the third unit. Okay, the third unit was the okay. Yeah. The last class, okay, before the lockdown, okay, this unit number 3 I have completed, single station manufacturing cells and automated production line. Uh, yeah. Okay, system configuration, work part transfer mechanism, storage buffers, control and production line. Okay, so these are the types, okay, of the automated systems. Okay, linear transfer mechanism, the cart on track conveyor systems. Okay, this walking beam mechanism. Okay, rotary indexing machine. Okay, buffer storages. Okay, so these application of automated production line. So that in the third chapter that I have completed. Okay, in the production single station manual and automated cells. Okay. 378, yes. Yeah. And I have given one seminar topic, on this, okay, that is unit 2 and unit 3, okay. Unit 2 and unit 3, okay, I have the seminar topic was given. So about the single station manufacturing cell and automated production line. So in that single station manual and automated cells, I have complete application of single station cells, analysis of single station systems, fundamentals of automated production lines, application of automated production line, analysis of transfer line. So this, okay, this is the unit, okay. Mm, yeah. So 448 fundamentals of automated production line, manual assembly line. How you have to calculate, that is continuous transfer, synchronous transfer, asynchronous transfer mechanisms that I have explained. Okay, this is the summary, okay, of the third unit. Okay, and analysis of single model assembly line. How you are going to calculate. Okay, then the and this, okay, about the automated production line, fundamentals of automated production line. So in that, okay, only fundamentals. In that, system configuration again, that I have explained. Okay, several possible layouts: L shape, U shape, rectangle shape, circular shape. Okay, linear transfer and other transfer mechanisms I have explained. Carton track conveyor systems, rotary indexing mechanism, that's walking beam mechanism. Okay, storage buffer. Okay, those particular things. Okay, so that this completes the syllabus. Okay, of a sim. Okay, so today I'll stop here. So I'll just touch upon first topic, second topic, and this thing. First topic is related to the introduction of automation. In that, you have just summary of what you have learned in this particular subject. Introduction to automation, manufacturing systems in industries and products, manufacturing operations. Okay, how many operations, production facility, what production facility does that particular automation, that layout has. Okay, production relationship. Okay, what is the product and what is the production relationship, which type of product you are manufacturing in which line. Okay, mathematical models of the production performance, like say your MLT, manufacturing lead time, and your PC. Okay, plant capacity, availability, utilization, WIP, TIP, all those things will come in this. Okay, models, in the mathematical model. And the manufacturing cost, how you are going to calculate. Okay, cost of the component, how you are going to calculate manufacturing cost. Basic element of automated system, advanced automation function and level. How many levels of automation are there? What are the advanced automation functions? Okay, are there in that particular first topic you have learned. Second topic, material transport and storage system. In that you have learned introduction to material handling, different types of material handling system. Okay, and material transport equipments. Okay, what are the different equipments in that you have learned. Okay, carton track, the cart. Okay, then you have learnt about the trailer. Okay, AGV, different types of AGV, automated guided vehicles. Okay, and the other conveyor systems. Okay, see, and so forth. And the analysis of material transport system, that you have learned. And then the storage system performance and location strategies, where you are going to store, what are the location strategies. Okay, how you are going to evaluate the performance of that particular ASRS, automated storage, or the storage system. And in that again you have learned conventional storage methods. Okay, conventional storage method and equipments, how you are going to, that is your drawer. Okay, and then the bins, and then racks. Okay, so those are the conventional storage equipments. And automated storage system, ASRS, automated storage and retrieval system. engineering analysis of storage system. In that again you have learned corrosal system also, okay, analysis of ASRS, automated storage system, and corrosal systems. So that you have learned. And then the next is I have taken inspection technology, inspection fundamentals, automated inspection, okay, contact and non-contact type of inspection, okay. With the help of touch probe sensors, we are using that. CMM, coordinate measuring machine, surface measurement, machine vision system, okay. Other optical inspection methods, non-contact inspection methods. So these are the things you have learned in the 5th unit. And the 6th unit, 4th unit is automated assembly system that I have taken in fundamentals of automated assembly systems, system configuration, what are the different configuration of the system, part delivery at workstation, how you are going to deliver the part at workstation, individual workstation, either it is a single station assembly or a multi-station assembly, or if it is a partially automated or inline configuration, okay. So how we are going to deliver those particular part to the workhead, okay, that you have learned. Application of that, quantitative analysis of each one assembly line, okay, station, that you have learned in the chapter number or unit number 3, okay. And unit number 2 I have explained, yeah, unit number 4. Unit number 3 is related to single station manual, cell and automated production line. So this is the total, okay, the MTech portion, okay, for the, so this is about the summary, okay. Just now I have whatever I have explained, this is the summary of that particular the total syllabus, okay, of this particular unit, okay, unit wise this thing. So first unit, second unit, third unit, okay, is related to the automation, okay, storage system and manufacturing cells, automated production line. And 4th unit is related to the automated assembly systems. 5th unit is related to inspection technology, how you are going to inspection, how you are going to do the inspection for the the assembled parts, okay. So today I'll stop here. Thank you.